Okay, this infographic that I'm going to walk you through in this video is probably the most useful in terms of how we move back and forth between a representation of a number on a computer and the decimal numbers that live in our head. All right, so it's hexadecimal, but what we talked about in the last section of this infographic book is that hexadecimal is just a way of representing bits, a bit pattern. All right, so we're going to take a closer look at this and remember what hexadecimal is at a glance. You have a sequence of symbols, 0 through 9, A through F. A through F takes on the decimal values 10 through 15 if you look at it on a digit by digit basis. Okay, so we know those things. One digit is equal to one nibble. All right, so a byte is 8 bits and a nibble is 4 bits. So that's a definition that you should know about. So because we have a nibble, all right, it's 4 bits. With 4 bits, I can represent 16 characters or 16 symbols. And that's what I'm doing with hex. All right, so what we're going to be doing is looking at these symbol values, and we know how to convert each one. We know that, for example, 1010, that if you convert that in binary to decimal, that would be 10. So that symbol A represents 10. Okay, so these things are all review. All right, so what I want you to be able to do is simultaneously, or at will, go between the symbol representation, the 4-bit pattern, and its decimal value. So that's just a matter of using it and becoming fast at moving between those 3 concepts. All right, so at this point, what I want to do is talk about representing larger decimal numbers where we have combinations of bits. So in this first case, I've got 8 bits, all right? An 8-bit pattern can be represented in hex with A9, all right? So we know what that would be. That'd be 1010 for A and 1001 for 9. All right, so what does that represent in decimal? Well, it works the same way that we did with binary, where we take a positional representation. So this would be the 16 to the zeros place. This would be the 16 to the first place. All right, because I have A, the next thing I'd do here is I'd take 10 times A. I'm sorry, A is 10. 10 times 16, and I get 160 coming out of this A position. Okay, then I'm going to take 16 to the 0, so that's 1. All right, 1 times 9 is 9. So I get 9 coming out of this least significant nibble position. Okay, so to get the final decimal number, I add these together and get the result. Okay, so that's the key idea, is that it works in a positional way just like before. So let's go over one more example of that. Let's take 1C8. All right, so 1 is a hex symbol. All right, the 4-bit pattern would be 0001. We know what C is. C would be 12. The 4-bit pattern is 1100, and then 8 is 1000. Okay, so then I take the positional weighting. Okay, so I have 16 squared. 16 squared is 256. So there's 256. Then I take 12 times 16, and that's what comes up in the next position. And then I have 8 times 16 to the 0. 16 to the 0 is 1. So then there's an 8 here. I add those together, and I get the decimal representation for this bit pattern. Okay, so now let's talk about going the other direction. Now let's go from decimal to hex. All right. So we did this with binary, but binary, it ends up being lots of steps because you're dividing by 2 each time. So when you do number conversions, I like to work in hex because it's really easy to convert the hex pattern back to binary. And usually you don't even need to do that. If you just know the hex pattern, that's usually what you need. Okay, so let's walk through it. So remember what we did with binary. We took the number that we're trying to convert. So this, look at 47. 47 divided by 16. that is 2. All right. And then we look at the remainder. Okay. The remainder is 15. Okay. So now let's go to the next step. 2 divided by 16 is 0. All right. And so we just read up, and what we get is 2f is the number representation. Okay. So that's the process every time. Let's go to another number. Let's look at 456. All right. I can take 456 divided by 16. I get 28 with a remainder of 8. All right. So from there, I take the 28. 28 divided by 16, that goes in once, and the remainder is 12. And so from there, 1 divided by 16 goes in 0 times. Okay. And so I take that 1 and I read up, and I get that the number is 1C8. All right. So works very much like binary, and so what you can do here with this calculator is you can try answers or conversions yourself. So dial up any decimal number, and this will tell you the sequence of divisions that happen along with the remainder. So you can practice that, and you read up and get the conversion to 3C5. And then the other direction is true as well. You can expand this back out to check your work. That's useful for exams. Do the conversion from decimal to hex, and then check your work by going hex back to decimal. Both directions work for that. So this is an important infographic. I hope you play around with this to get to where you're pretty quick at doing number conversions. All right, this is one of these kind of things that becomes easy when you first try to do it, and you tend to under practice because it does take several reps to get this down to where you can do it pretty much by instinct. And that's where you want to be when you do exam 1. All right, so that wraps that up. Hopefully you play around with this and learn this number conversion down cold.